Okay, now we're going the other way. Convert each number from decimal form to the given base. I don't care which of the methods you use for this one. I usually use the shortcut on these. I want to go from change 65 into base 7. Okay, it goes 9 times with, and remember on this you have to keep track of your remainder. So 9 times 7 is 63, so the remainder is 2. 7 goes once with a remainder of 2. 7 doesn't go with a remainder of 1. So I get 1, 2, 2, base 7. Okay, remember the other thing you do is you can look at the powers of 7. 7 cubed is too large. And 49 will go into 65. You figure out there's one of those. And what's our remainder? 15. 16. How many times does 7 go into the 16? It goes twice. So that's how we got the 1 and the 2. This time we're looking here rather than the remainder. And then we have 2 1s left over. So that's where we get the numbers from. Okay, I like to use the shortcut on that one. 34, we have 2730. And that is to base 16. Okay, I'm going to have to use a calculator for this. 3730 divided by 16 goes 233. 233 times 16 is 3728, so our remainder was 2. Okay, now I divide 16 into 233. Goes 14 times. 16 times 14 gives me 224. So the remainder is 9. 16 into 14 will not go. So I have a remainder of 14. Okay, I copied the problem wrong, so based on what I'm getting, it's, okay, A is 10, B is 11, C is 12, D is 13, E is 14, so that's equivalent to an E. So we're getting E, 9, 2, base 16. Okay, I goofed. That should have been a 2, but as long as we've worked a problem, that's the main thing. So, okay, E92 base 16. All right, in 38, we have 70893. Nope, sorry, wrong one. 1, 2. I don't want to copy this one wrong. 3 8s. This one. Okay. So I want to start my 12, 8, 8, 8, divide it by 8, and keep track of the remainders. Clear my calculator. 12,888 divided by 8. Okay, I get 1611, so the remainder on that one is 0. Alright, I divide 1611 by 8. I get 201. And so that's going to be a remainder of 3. Alright, so 201 divided by 8 is 25 with a remainder of 1. 8 into 25 goes 3 times with a remainder of 1. 8 into 3 won't go, so a remainder of 3. So I'm going to have 31130. Base 8. And let me double check that one is correct. Okay, we're just going to do 3 more. If we're asked to change from base 8 to another base other than base 10, we actually have to do 2 problems. In the first problem, we change from base 8 into base 10, and then we go from base 10 into base 5. So I think about my powers of 8. So we have 2 times 8 plus 7 times 1 equals 16 plus 7, or 23 in base 10. Now I take my base 10 number and I want to convert it into base 5. So I'm keeping track of my remainders. 5 goes 4 times with a remainder of 3. 5 does not go, so we get 4, 3, base 5. 4, 3, base 5. Now, we talked about a short way to do converting from octal to binary and binary to octal. So that's what we're doing in the last 2 examples. 2406, base 8, and we want to go into base 2. We could go through the process we did in 44, but there is a quicker way to do it. Remember the conversion table on page 164, table 12. By representing each of the numbers in the base 8 number with 3 binary digits. So 6 is 110, 0 is 000, 4 is 100, and 2 is 010. So I don't need the leading 0. So that would be our base 2. So basically we're representing each of these with 3 digits until we get to the leading one. We don't need any leading zeros. Alright, and 48, we have 2, 50 is the other one. We have, okay, I have trouble seeing these. 110, 10. Then 1, 2, 3, 4 ones and a 0 and a 1. And that's base 2. So now we're doing the reverse. We want to group these in groups of 3 and read them from that table we were just looking at. So down here at the end, 101, that's a 5. It's 1, 2 squared plus 1. So that's a 5. The 111 would be a 7. The 010 is a 2. And the 11, assuming that would be a 0 in front, 011 is a 3. So that's base 8. Okay, that should give you enough information to prepare you to do the online homework.